Awesome. Go ahead and get the party rolling. There you go. So can you guys all see my screen okay?
Yes.
Okay, awesome, awesome. So, just a bit about our group. I finally changed our group picture. Gonna be doing that officially later. But we're just a bunch of who want to get together, learn about AWS Cloud Security or just cloud security in general. We're just really trying to get out there and kind of learn from each other, good practices, how to build secure environments, and just, for me, in my case, I'm just learning as a newbie in the security industry. These are some of the topics that our group will have from time to time. Some of them we've done talks on, some of them we haven't. So if you see anything in here that you'd be interested in giving a talk in the future, definitely reach out to me either via Meetup, or you could find me on LinkedIn. Let me see. So I always like including our the shared responsibility model that AWS has. I really want to make sure that as customers and as users, because this is a user group first and foremost, we really are able to take care of ourselves, and be able to create secure environments in that case, because Amazon is secure of what's of the cloud, the security of the cloud, and we're focused on the security on the cloud. So this is just if you guys want to help our reachability and kind of be able to bring your friends and colleagues into the group, we're always looking for other people to join and to help educate with the presentations. In the future, hopefully soon, with COVID going on, it's still been a struggle setting this up, but we are planning to have like AWS security specialty certification study groups. So in the future, definitely be on the lookout for that. If you are interested in helping plan or being a mentor for potential mentees and for people who are wanting to get certified, definitely let me know, and that way we can come up with a session sooner. So that'd be great. We have a code of conduct. Really, and I have it in there. Just don't be rude. Don't be mean. We're all here to learn and in a safe and friendly environment. And then these are upcoming groups. We have one Wednesday, May 27th on Kubernetes security and using Terraform to drive security in AWS. We have next month on June 10th. We have, we're probably gonna have it virtually. I'll be updating any changes, but so far all of our meetups are gonna be virtual. We're gonna have addressing cloud security with OPA, and we're looking for a second speaker. And then I also posted the public sector summit online. AWS, asked us to kind of share it because it's not going to be in person this year, but it is online and it's free to register. So you can definitely go ahead and register. But that's really all I wanted to share. At least in regards to the group. If you're new, definitely welcome. Sivia mentioned in the chat, her information. Fugue is actually going to be sponsoring today's meetup, and I'm going to go ahead and turn it over to Drew, I believe, and they're going to do a short little promo, and then we can get started with Tim. Okay, awesome, guys. So.
Yep. Thanks, Sarah. I'm Drew Wright, one of the co-founders of Fugue. Thanks for having me out. Looking forward to getting back to in-person meetings with meetups with pizza and beer and all of that fun stuff. But until then, here we are. I'll be brief. I don't have any kind of presentation or anything. So Fugue is all about cloud infrastructure, security, and compliance. And we're a little different than the other kind of cloud security tools out there. We believe cloud engineers and developers own the security of their cloud environments. You can't really separate the concerns and kind of have your application teams here and the DevOps teams here and then security over here and compliance over here and expect to kind of keep your infrastructure secure because things move too fast. We're updating our environments all the time. But the great news is with the cloud is because cloud is 100% software, and cloud security is all about the secure configuration of your infrastructure. It's all programmable. We program our infrastructure all the time with things like CloudFormation or Terraform, and we can program the security of that infrastructure with tools like Fugue. So what Fugue does is it scans your cloud environment, and by scanning, we don't mean we're looking for specific things you've decided might be bad or scary. But what Fugue does is it actually surveys your cloud environment and captures kind of the full state configuration information of your entire cloud environment. And by doing that, we can perform a number of functions against that information. We can provide kind of dynamic architectural diagrams of your infrastructure. You can zoom in and see configuration details, compliance violations, understand how your resources relate to each other and understand those dependencies. This can be really helpful for a number of things. One, just kind of making sense of what you have in the cloud. It can be really difficult to kind of see everything you have by clicking through the console. You can quickly find like orphaned resources that you aren't really aware are running. And keep in mind, if you have an orphaned resource out there that's running in your environment and you're not aware of it, that also means you're not patching it, you're not scanning it for misconfiguration, vulnerabilities, that kind of a thing. And a lot of kind of recent cloud exploits that we've seen oftentimes start with a malicious actor finding a known kind of vulnerability on like an EC2 instance that the customer wasn't aware was actually running in their environment. So you have to know what you're running and have visibility into everything. So once you're up and running with Fugue, that takes about 15 minutes to kind of get that full picture of your cloud environment, validated against any number of out-of-the-box compliance frameworks. And you mentioned, Sarah, next month is OPA. We are big fans of OPA here for policy as code. What OPA is, it's the Open Policy Agent. It's an open standard for policy as code. If you use Kubernetes and you're concerned about security, you might be aware of OPA. It's pretty popular in that community, and we're kind of, at least, helping, I think, lead the charge for applying OPA for policy as code for the entire kind of cloud infrastructure space, if you will. It's really powerful, really easy to use, and I think when it comes to kind of languages, probably best to avoid proprietary solutions because they can kind of lead you down into some dead ends. So check Fugue out. There is a free forever plan for individual engineers called Fugue Developer. You can get that if you go to Fugue, it's fugue.co/go. And sign up. It's a SaaS product, so there's nothing to download or install. There's no agents, and you'll be up and running in about 15 minutes. And again, it's free forever to use, and it's pretty cool. I think it kind of saves people a lot of time and headaches in trying to move fast in the cloud and stay secure. So check it out. Let me know if you have any questions, and thanks again.
Okay, awesome. Thanks, Drew. Thanks, Drew, for that. I went ahead and put y'all's link in the chat, so if anyone wants to take a look at that later. But then in that case, we can go ahead and get on started. So Tim, you're on. Let me make you 1 second. There, yeah.
All right, is that screen share coming through okay?
Yep.
Awesome. Sorry about the delay that moved my unmute button on me. So hi, everyone. My name is Tim. I started attending this meetup maybe a year ago, was the first one I went to, and presented back in February on security automation. And kind of went 100 miles an hour for an hour, and talked with Sarah and mentioned that I've been doing a lot of research on the offensive side of security in AWS. I personally had a mission maybe 18 months ago to get smarter about, well, what are the tools and tactics and techniques that me as a security architect has to defend against? And what are the things that I need to be looking for when you talk about Fugue? What are the misconfigurations and unknown dependencies and orphaned resources that are out there, and how would an attacker go about exploiting those? So I'm personally a big fan of reducing your surface area, reduce your footprint. Anytime, my coworkers laugh at me at least once a day in Slack, I hop in and I'm like, can I delete this thing that I don't like? And there's 50 of them. It's kind of I get joy out of going through and deleting things that we don't need anymore and finding new techniques to figure out what we don't need and kind of reducing the chaos of the environment so you can pay attention to the things that actually matter. This presentation is specifically tailored to try to speak to everybody. So I try to make no assumptions that you have anybody who's receiving this presentation has any expected level of experience or expertise on AWS. I'll do my best to step into each of the concepts from a foundational level, but I will talk about some advanced stuff. And the whole idea is I just want to give you some ideas to think about. As a cloud security practitioner, most people are on the defensive side, and these are things that we might need to get smarter on as a community, areas of research, areas of concern as you're developing requirements or implementing solutions. So how I've split up the two sessions today, because especially virtual, this is a whole lot of time to be listening to one person. And I don't like slides. So there's going to be very few words on these slides. And I'll make these slides available to everybody. So it's mostly concepts and pictures and stuff like that. And I try to make it entertaining. And I'm only going to do slides for the first half. And then we'll take a break. I believe it's 7 o'clock is the planned break for 10 minutes. And then after that is entirely demos. And they're going to be live. And they may or may not go well. They've been going well so far. So I'll say a prayer to the demo gods. But there's some really cool stuff, and it'll be interactive, and I can take questions as we're doing it. So yeah, let me get started here. So my background, integration and architecture. Security has been prevalent throughout a whole lot of identity and access management, data analytics. However, I end up doing a lot of development in DevOps, because if I want to get my architecture solutions out the door, I need to be able to write Terraform and Lambda Python functions and integrate with DevOps build processes. So just like when you're operating in cloud and everybody, networking is code now, and everybody has to dabble in networking. Now people are starting to have to dabble more in DevOps and development, because at scale, and for security reasons too, it's at some point it's not okay to be clicking around in the console. You need a repeatable solution, a solid code base. It's in configuration management. You have protected branches and release processes. That's how you're going to have a secure code foundation to your environment. So I've been drinking from the DevOps fire hose for the last probably 3 years. My AWS experience, I've been working in it for 7 years, some pretty large environments, worked in GovCloud, worked in some of the disconnected regions that you hear about in this area. That's the customer that I support now. The current environment that I'm laser focused on is about 70 accounts, and we use Terraform across all of it. to establish like account baselines. So my security role is to figure out like what are the common configurations that we need to ensure exist in every account, and provision that and do drift detection and respond when things get weird. So cloud security, what do I mean when I talk about cloud security? How is this different from like information security or cybersecurity? So we talk about the shared responsibility model. Everybody should be fairly familiar with that. But what I want to get into is what does that actually mean? So I'm not going to play this now. This is like a 3-minute video. And I think it's very telling on what AWS thinks about as their responsibility as they innovate on their side of the security equation. So the provable security stuff that plays out in Nitro, plays out in Inspector, plays out in Access Analyzer. So they hired a bunch of math people who came in and said, I don't understand what's so hard about security. Like you can do proofs. And by proofs, like let's explain every possible configuration path, and things that are vulnerable are a path that you didn't consider. But if we can define every path, we can have a provably secure solution. So their Nitro cards in their secure boot process. This is kind of the underlying hypervisor on your EC2 instances, at least the new ones. They talk about the speed, the efficiency, the cost difference, but having a secure boot that no administrator can touch, it's immutable, huge security differentiator. And this is actually one of the foundational technical arguments that AWS is making in their protest of the DoD JEDI contract, that there was no criteria in the contract to assess something like this that AWS, and I personally believe, is a fairly big differentiator between Azure and AWS. Yeah, I'm not ever going to say that one's better than the other, but this is certainly a differentiator. So now something that's a customer responsibility. This is the one you hear about all the time. You don't necessarily hear about the flaws or vulnerabilities in AWS's infrastructure. But to note, like one thing, when Heartbleed came out, the SSL TLS vulnerability, and there were insecure, vulnerable protocols being run on all of AWS's load balancer fleet. So everybody has to go and patch their web servers but AWS is the one that runs those implementations on their servers. So they looked in, they found the vulnerability, they wrote their own crypto patch to it and had it deployed to like 99% of their customers within the day. And the patch was probably about 50% the size of what the OpenSSL team came up with in the first place, because they ripped out a whole bunch of stuff that they didn't need in the process, and now they're running their own crypto. They have their own SSL libraries that are significantly smaller, again, smaller footprint. But customer side, it's the S3 buckets you hear about all the time. It's the compromised keys. AWS does what they can to try and educate customers, to try and give you clues in the console, like, hey, you are opting in to make this bucket entirely public. Is that cool? And you have to say, yeah, that's cool. But it does get a little bit more nuanced than that, because Capital One is one of the most sophisticated AWS implementations out there, and they're fantastic at security, and they got breached. And I have some friends that work there, and I feel really bad for them because the path to that breach was really interesting, and we're gonna actually demo it tonight. But it wasn't a public bucket. They didn't make their bucket public. It was a web application firewall vulnerability that had credentials that allowed you to the back end to a private S3 bucket over the AWS API. Is at least the common understanding that I'm aware of. So if anybody knows more than that, feel free to correct me at some point. So back to cloud security and what do I think of when I say cloud security? Well, it's inherently global. So you're worrying about API endpoints that are on by default all over the world. So if you don't run CloudTrail in one of the Asian Pacific regions, well, it's out there. An attacker can start trying to spin up resources over there. And if it's not a global service that they're interacting with, like IAM, you can do a lot of stuff in a region, and there are blind spots to GuardDuty, to CloudTrail. So the inherently global nature is great from an architecture perspective and an availability perspective and a performance perspective. From a security perspective, I try to talk to my customer and say, what regions do we want to be in? And I'm going to do everything possible to restrict activity in every region except those. But you can't do that with a global customer. API driven. So when we say things are code, well, you talk to networking and databases and the identity management system and your servers all on API, which means it's all code. One of the things from a security perspective is it's a well understood API that is going to behave using the same credentials. You know, you can use your same credentials for a database and the network. So things get pretty interesting there, and it's pretty nice for an attacker to be able to use credentials and pivot across very diverse services that way. It's dynamic. So back to the fugue statement that there's all kinds of resources that are temporary, getting spun up, shut down, left behind. When you talk about auto scaling, it's not a concept that really exists in a data center. They have their named servers. They're tracked in probably an Excel spreadsheet or some fancier configuration management software inventory. So it's a blessing and a curse. Is your environment is a moving target, but at any point in time, you can get a 100% accurate inventory of what you're running because of the API. So S3 list buckets, there's all my buckets at this point in time. And you can track differences against that as it changes over time. Your non-traditional infrastructure, this is your things that don't exist in a data center, like Lambda, function as a service. Super powerful, but also not as well understood by your career technology professionals or folks coming in and trying to learn and drink from a fire hose about these hundreds of services that are available. So when you have non-traditional infrastructure, you don't have a full understanding of the power of that infrastructure, and you get misconfigurations. So what I'm saying is there's a talent gap when you start talking about cloud, where you don't get folks that can just specialize on their swim lane anymore. You don't necessarily have a database person and a network person, your identity and access person, your sysadmins. Like, it's starting to blend all of it. And it's really hard for the practitioners to keep up. And then public access, it's a public API. So just throw your data center out on the internet. Let's have fun. Nothing could go wrong. I'm not gonna spend too much time on this. The attack matrix from MITRE is something I find super interesting. So I'll just leave that link with you. A lot of the exploits and vulnerabilities that we talk about can all be mapped back to this matrix. So that's some good light reading for the weekend if anybody's interested. So global infrastructure, check out this link. It's awesome. It just gives you a taste of where are all the regions, where are the availability zones, what's the difference, what in the world is a local zone. Go back to reInvent last year if you want to learn about that. Basically, they're dropping mini data centers in like Los Angeles for super low latency. But this is an interactive diagram, super cool. So an AWS account is where I think is a good starting point to step in here. So when you have an AWS account, there's multiple ways of accessing your services. So AWS is running all these services, and each of those services has their own API, and it has its own API in each region that service is available. When you talk on your web console or your CLI, it's abstracting those APIs for you. But really what's going on behind the scenes is, if you look here, I don't know if my mouse shows up on the screen share, hopefully, but you have your service like EC2, and then you have your region like US East 1 at Amazon AWS. So a whole bunch of APIs out there. That's why when you're using the CLI, you need to specify what region you want to be talking to. And that's why in the console, you need to do the dropdown for the region-specific services because you're talking to a different API in the back end. So the ways of interacting, there's the web console, which is talking to the API. There's your CLI, your command line, which is talking to the API. And then there's SDKs. So that's how you would use Python or Java to speak to AWS. So what's great is all of these APIs and all of these interfaces talk to the same identity and access management system in the backend. It's AWS IAM. So that does your authentication of users and roles, and it does your authorization. So that's your IAM policies and deciding what are you allowed to do. And for the most part, the management events are all logged to CloudTrail. So we'll talk about some blind spots in CloudTrail later. There's actually services that don't log to CloudTrail, and that's really important for figuring out if you have valid credentials without triggering an alarm. You talk to an API that's not logging to CloudTrail and see if the credentials work. So moving on, what do you have in an AWS account? Generally speaking, and I'm framing this for the discussion today, these are the categories I'm going to talk about. It's IAM, and there you have your identities or principals. And those are both people and not people, like an EC2 instance or a Lambda function. Those are principals. Principals have credentials. It could be a username and password. It could be an access key and secret key. Or it could be using temporary credentials from STS. So you use those credentials to authenticate. So you're identified as the principal. You authenticate to be that principal. And once you do that, policies are applied to you. And it can be a lot of policies, and it gets really confusing. You also have compute resources, so EC2, Lambda, Beanstalk. You have what I would generally call infrastructure or networking. That's all your VPC and your subnets and your routing and security groups and NACLs. And then you have your data. So database services, disk volumes, EBS, S3 storage. Then you have relationships among accounts. So AWS organizations started off as a way to do centralized billing. So every member account in an organization, it's kind of an invite process. All the billing will roll up to the organization. So really convenient for, like, say a larger company that wants to keep its marketing department separate from its R&D department, separate from its operational service that it's providing. AWS has been investing heavily in organizations. It was just 2 re:Invents ago that they said the best rule of thumb for how many accounts is too many was about 10. They've blown through that. We're currently running 70. We have 200 in another environment. And if you're running your own infrastructure as code through like CloudFormation stack sets, or we use Terraform, that gets really manageable. Also, they're starting to put some of that automation into organizations itself. So you want to be reading about like organizations' service control policies. If you invest in organizations rather than like we keep our our policies in Terraform. It's pushed out and drift detected and everything. But you can put IAM policy restrictions in service control policies at the organization level and govern those restrictions or allowances across your entire organization, so at massive scale. You can also start to do something with like organization-wide CloudTrail or organization-wide guard duty, which is the managed threat intelligence service. And you can even delegate accounts. So we like to keep everything possible out of the organization account because it's already really powerful. So I'd rather have a security account do the guard duty, scanning, detection, all that kind of stuff. Many other services. So you can delegate another account. So the yellow accounts are kind of ones that like a central team may be running. And then you can have tenants all throughout. So one of the best practices here is to minimize your blast radius. So if one account got owned, you want to prevent pivots to all the other accounts. If everybody's sitting in the same account, a lot of things are going to go down. And very importantly for this discussion is you have relationships. So accounts can trust each other. So you can establish principals in accounts that trust another account, and you can switch role from account to account. So that's a really good pivot. And that's something that Access Analyzer is starting to help customers uncover. Additionally, you can share resources between accounts. So your private S3 bucket can be shared with another account privately. Your EBS snapshots, your RDS snapshots, you can share a VPC with another account. So these are really important pivots and something that an attacker certainly pays attention to. So IAM, you have users. I try to use them for nothing. If you can federate into your environment using single sign-on with like Active Directory, federation services, Okta, Keycloak, or even AWS SSO now, definitely do that. That helps you get rid of IAM users. So you would authenticate to, say, Active Directory, and then you would pick a role. So here's your external user, Active Directory. Nobody wants another identity store. That's another place to look to start developing orphans, old accounts, old credentials. You don't want it. So you're probably investing heavily in Active Directory. Use it. Federate in, use short-term credentials. Doesn't matter so much if those credentials get taken. They're not going to live very long, although we'll exploit that later. And then all of these things leverage the same IAM policies. How those policies work, whether it's a surface control policy, a resource policy that's like on an S3 bucket, directly attached to an IAM user, or a managed policy attached to a role or user. If there's anything denied, it's denied. So that's the explicit deny. So no, you can't do EC2. Then, so all the policies are going to come together, and you're going to look at them. It doesn't matter. They don't really override each other, except service control policies are a little special. So you look for that explicit deny, and if the evaluation logic doesn't see it, it's going to see, is this action that the user is trying to take allowed? Are they allowed to list buckets or put an object? No? Okay. Well, you didn't deny it and you didn't allow it, so it's denied. So it's a default closed system, which is absolutely fantastic about AWS. Azure is the opposite, default open most of the place. So if you're studying for the security specialty, super important to know. Just know this flow right here, and you should get a lot of questions right. So this is an offensive talk. So what can you do with IAM? Where can it be compromised? It can be compromised at the client. So my laptop, I have a AWS credentials file. If you use CLI, you have this file that's bottom right in black. Those keys are very old at this point, so try them if you want. So these are the things that get checked into GitHub sometimes. Or if you give your application these access keys to talk on the CLI. So anytime you're talking access keys leaked on GitHub, this is what they're talking about. On the host, at rest for application use, there are secrets stored in there. Those access keys are given to applications running on EC2 instances. It's recommended that they assume an IAM role through the EC2 instances, but not all applications can do that. So these keys are going to be littered everywhere. If it's an identity provider, so like Active Directory, password resets, social engineering, more complex would be an exploit, but typically it's going to be social engineering of your Active Directory password. And then again, the public exposure. Even once you check something into Git, if somebody just removes it and puts in another commit, that commit history is still there. So even if you do catch yourself and clean it up to some extent, your commit history may still expose that key. So what is an attacker going to try and do? Well, they can create new principals. So create users or roles if they have permission to. You can create credentials. So I could find a user that doesn't have a password, that only uses CLI, and put a password on that user. It's going to be pretty low level in terms of logging for triggering any kind of radar that, okay, so a user got a password. But our users use passwords, that's fine. Trust relationships. So in this picture, here's a role. Most people pay attention to the permissions tab where you start. Hop over one to that trust relationship. That says the external accounts or services within your account that can assume the role. So you could take an existing role. You don't need to know passwords or access keys or anything like that, but trust your attacker account. And then your attacker can come in and assume that role from their account and start doing some damage. Updating existing policies. So if you're not even creating a new policy, just go into an existing policy. It'll get triggered as a new version of the policy, but that's a little bit quieter than a new policy or attaching a new policy. So just if you have permission, update the policies that already exist and start expanding permissions. You can start opening access to resources, and then for persistence, you can automate your persistence. If you can have a Lambda function in there that is getting triggered on a daily basis to recreate an IAM user for you and send those credentials somewhere, that's something that an attacker might look to do. So this is like one of my favorite blog articles ever. You'll hear me talk about Rhino Security Labs a lot today. They do a lot of offensive research as it relates to AWS. And what they've done is, I think the latest update from like December, there's 20-something privilege escalation paths that you can use in AWS to either expand your permissions or establish persistence. So just for example, so you could launch a new EC2 instance with an existing policy. So EC2 instances can have a role assigned to them, just like a user can assume. And that might already have a policy, and EC2 instances have roles, so no big deal. And if you can get on that EC2 instance, you can now do everything that role can do. And it's only attributable back to that EC2 instance, not the person on EC2 necessarily. So really good article, check it out. There are also some scripts that can automate the enumeration of an account. So from that same group, Rhino Security, you can run an AWS escalation script that will, with the right permissions, you give it your access key, can run through the environment, look at every principal, and define or help identify which of those exploits on that blog article, those 20 some odd escalation methods, which of them apply to which user. So now you know this build role, probably a Jenkins server or something is using it, is probably susceptible, in this case, confirmed susceptible based on the IAM policy associated with that role, to do privilege escalation by creating an EC2 instance or passing a role, an existing role, over to CloudFormation. So really helps an attacker get a lay of the landscape coming into an account. What do you want to do? IAM policy is really daunting. So just take an iterative approach and tweak it and tweak it and tweak it and tweak it. And it will get stronger as you go. There are some quick hits, a little bit beyond the scope of this discussion, but talk to me if you want to talk some good ideas for reeling in IAM. For credentials, get rid of the old credentials. Access keys beyond a certain age. I've some scripts that I've used personally that can go through and audit access keys just like you would a password and start inactivating them. I always recommend inactivate it before it deletes, because then you see who screams. So when you break the build server and they say, why did this break? Well, you can re-enable the key and get them to rotate their key, so at least builds can keep happening that day. Auditing in CloudTrail, know what you're looking for. There's a lot of methods out there to surface high-risk CloudTrail actions. And then put the security services to work. So GuardDuty and Macy do a really, really good job analyzing CloudTrail for you, among other things. So a really cool thing that GuardDuty will do is it does have a machine learning aspect to it. So it will watch your principals, and for 30 days, it will get kind of an understanding of what are normal behaviors for this user. And then after those 30 days, if there are API calls that that user makes that CloudTrail hasn't, or that GuardDuty hasn't seen before, it'll raise an alert and it'll let you know, here's something new that this user is doing. Use Access Analyzer, Access Advisor, and you can start reeling in towards least privileged. VPC. So these are all the things that are in your VPC, and it's a lot. So it's your logical network enclave. It's private and segregated from other enclaves. It has all your routing, has your access controls. It also has a whole bunch of gateway type things. So it has your internet gateway. So think the router that connects your private network to the internet. It has NAT gateways. That's kind of like the router that connects your private instances so that they can reach out, even though they're on a private IP. It'll do that public to private translation for you, and they can hit like an external repository to do update their packages. Something really cool and new and kind of horrific is traffic mirroring. So this was announced last summer at the security conference, Reinforce. This is the first time that at an infrastructure layer, you can do full packet capture in AWS. Before you had to do some wizardry to run traffic through an instance and grab it there, but this isn't like normal networking in a data center. So what traffic mirroring can do is any elastic network interface, whether it's at the edge of your VPC or on an instance, you can establish a mirror and forward it to a mirror target. So this is really good for troubleshooting. Some security teams want to do it for compliance, passing this to some sort of third-party product to do analysis. But for a first time for an attacker, they can establish a mirror and target and forward to a resource that they own. And if the customer isn't aware that mirroring is a thing, they don't know to look for this. And up until recently, it was kind of common practice to have a soft inside to your network. So all the private instances, maybe it's okay if they're not talking on encrypted channels like SSL, because there's no broadcast traffic inside of VPC is what we've been taught. Well, now you have a lot of clear traffic flying around and you have mirroring that you can just grab it. So I have traffic mirroring disabled. We'll turn it on if somebody needs it. There's just a little bit more context to to how a VPC is built out and the relationship amongst things, but I'll keep going through. So for exposing allowed network paths at your subnet layer, you have NACLs. So these are, unlike a security group, you can deny on a NACL, but this is one of the few things in AWS that is default allow. And then you have security groups, which are stateful. So the difference being, you don't need a matching outbound rule. So in a NACL, if you're allowing port 80 inbound to a web server or 443, you also need a NACL rule to allow that traffic back out. And that's probably going to be on an ephemeral port that you can't predict. So that's why you see allow all traffic out. It's because of those ephemeral ports. Customers would never figure out AWS if that didn't exist. Security groups, you don't need the outbound rule. These outbound rules here are actually for EC2 initiated traffic to get out. But that's default open as well. So security groups are kind of the bane of my existence because developers will constantly put their public EC2 instances on the internet and open up all ports because that's how you get things to work. But GuardDuty will make it very clear all the port scanning and brute force logins that you're facing. So use a combination of GuardDuty and probably config rules to audit those security groups. So what can be done with the VPC? We talked about the traffic mirroring, route table updates, and rules configurations to open up access to resources. Attaching new security groups that already exist is another way to pivot and gain network access. Lambdas can be launched into a VPC. They bypass security groups. So if you're having trouble getting through a security group and you can launch a Lambda in there, then you can talk EC2 API and not be subject to security groups. And then Systems Manager is one of my favorite things. Systems Manager, it does a lot of things. It's a big service. But one of the things you can do is get a shell to a server over the API and not the network layer. So that your VPC routing and security groups, Systems Manager is only talking API. So my go-to when I'm developing a server now is I'll spin it up. I won't make it public, so it's only a private IP. I don't give it any security group rules, so nothing allowed in. And I don't put a private key, a public key on it actually. So when you launch an instance, you define which key you want. I don't give it one. So it is completely closed. And then Systems Manager can be used to get to that instance. So it's a great way to kick the tires on new solutions. But you can also use it to get into just about any instance without having credentials. You just need the API credentials in AWS, not the server credentials necessarily. EC2. So what can you do to EC2 if you don't have credentials? Well, I just mentioned about how there's so much EC2 just hanging out there open on the internet with bad security groups and unpatched. So you're going to have very frequently RDP and SSH ports open to the internet, and they're going to get brute forced. So by brute force, I mean there's botnets out there that are scanning the internet looking for public port 22, public through 389. They're not even port scanning necessarily because they know those are the ports they're looking for. And they're just going to hammer away trying to log in all day. They don't care much about attribution because it's just a botnet. But you're also going to get application exploits. So looking at well-known ports, did you put the default port for PostgreSQL out on the internet? Well, older versions of Postgres have exploits. So let's just see if that port is open. And then, okay, we can reach it. Let's try some of those exploits and get in. It sounds like it wouldn't happen, but I've seen it. I've seen a Postgres server that became, fortunately, it just became a Bitcoin miner. So it's very, very obvious to see what it was doing, and we shut that down, and there was no pivot. And then server-side request forgery is really cool. That was most likely the Capital One door that was left open. So that's going to be the demo later. If you have AWS credentials, EBS is a great way to get into a box. I'll explain that on an upcoming slide. And then Systems Manager as well. If you have API credentials, most, I'd say modern AMIs are running the Systems Manager agent by default. So if that EC2 instance can be given Systems Manager permissions, then that agent's going to reach out, register itself with Systems Manager, maybe without you even knowing. And as soon as it's registered with Systems Manager, any IAM principal that has Systems Manager permissions can now get a shell to that box. User data. So user data is, it's like a small script that can bootstrap a server. So when you launch an instance or even restart an instance, it's going to read its user data, and it might tell it something like just do a package update and then go get some configuration files out of S3. That might be all it does, but it's root level execution and it can be updated. So I have a demo later where we update the user data and we install an Apache server and put a page on it, and that's exposed to the internet. That page could be server-side request forgery vulnerable. So something you can do something you can do with AWS credentials. Maybe not many, but you have to have some credentials. And then the new one with the packet capture. Get all kinds of secrets out of that with clear text traffic. So what can you do with EBS? So EBS volumes are attached to EC2 instances. Every EC2 instance, if it's EBS backed, is going to have a root EBS volume. Up until very recently, it was really hard to encrypt an EBS root volume. You can have multiple volumes, so multiple drives on there. So it might be common to leave your operating system on the root and your application installs on a secondary mount. More likely that the secondary would be encrypted, but a lot of the time not encrypted at all. So if you snapshot it, that is also not encrypted. If it is encrypted, you just need access to the KMS key that did the encryption, and then you can decrypt on the snapshot. Once you have a snapshot, and this can be of a running server, those snapshots can be shared publicly. They can be shared privately. So a public share would be something that, like bots would be looking for. A private share would be something that's a little bit more covert. So say I have a small footprint in this account, I'm going to be looking to get a snapshot of a server and privately share it to my own burner account. And once I have it over there, I can do whatever I want to it, and it's not going to show up in CloudTrail in the target account. What you can also do is right in the account, just launch a new EC2 instance off of that snapshot, just make an image out of it, and then launch off that image, or attach that to a running instance. So the cool thing about attaching it to a running instance is you just mount it and you can start browsing the directory and looking through it, probably finding all kinds of secrets. Let me see if okay. What else you can do? And I do touch on this in the demo if there's time. So that EC2 instance, I don't have access to this thing, but I do have AWS permissions, some. So I'm going to stop the instance. I'm going to take its EBS volume and I'm going to detach it, the root volume. Now I'm going to attach that root volume to an EC2 instance that I do have access to. I'll then modify it. First and foremost, put my public key on some existing users, perhaps. And then when I reattach that volume and restart the instance, I can now get in with my private key that matches the public key for SSH that instance. So some of these tactics, I won't get into it too much. Some are much noisier than others in terms of how much attention it's going to get from CloudTrail and from the security services. So just keep that in mind, that some of these tactics, they're pretty brute force. a sophisticated security team is going to see and hopefully prevent some of these methods. But I'll just throw it out there that it may not be as easy or as covert as it seems. So what would you want to do? Expanding network access, so you can pivot to more instances, see more traffic. You can leverage an instance profile. So the role that is on an EC2 instance, that is permissions. So once I get access to that EC2 instance and say it has a really powerful role because it's just been misconfigured and has a way bigger scope than needed, now I've elevated my privileges from what I had before, which was just some EC2 stuff, to now everything that this EC2 instance profile has access to, which is probably a whole lot of S3. The secrets at rest, that's what you're looking for in EBS. It could be AWS specific secrets. It could be access to secrets manager, which the server is going to have access to. Or it might be just application specific database credentials that you could find in there. And then, everything else. And what I mean by that is everything I've been talking about is AWS specific, but once you own a server, you own a server. And now all of your standard information security, cybersecurity, I say TTPs, tools, tactics, procedures, those are all in play once you have that server. I think S3 is one of the last ones we'll be talking about, and then we'll try and take a break at 7 and switch to the demos. So I appreciate everybody hanging in there with me. So S3, why is it so hard? This seems really easy, right? Like you launch you create an S3 bucket now and default lock all public access. When you unclick that, it gives you this giant box. And they're constantly tweaking it to like try to have a better success rate. So it kind of looks different by the month, but this is where you acknowledge that an S3 bucket is going public. But there are legitimate reasons for having public S3 buckets, such as a static S3 website, really common. But what if public doesn't matter? So first of all, any user in an account with S3 permissions has essentially full access to any bucket in that account with the default permissions. So you go here and it says bucket owner. All that means is any principal in this account, like any of them. So every user can get to that bucket. Every server role can get to that bucket if they have the appropriate S3 IAM permissions. So these are IAM permissions. These are resource permissions on S3. So yeah, what I say is like other resources that would be within scope for this access would be EC2, Lambda, CloudFront. The bucket policy is where you would start to get more granular and define like, okay, well, I actually care about who in the account sees this bucket. I'm going to start specifying like specific principles that can get in here now. But for like a log centralization bucket, here is just a good example. It's centralized Route 53 logs, and you can trust your organization. So now you have one place to collect all of your Route 53 logs or CloudTrail logs or whatever kind of logs, and you just trust your organization accounts. So it's a way to dial it in a little bit more. So what happened on the Capital One bucket was there was a web application firewall running on EC2. That was, of course, public. That's what a web application firewall does. It looks at the public traffic coming in and decides if this is good or not. So there was a server-side request forgery vulnerability there, most likely, which allowed the attacker to exfil the credentials for the EC2 instance. And they're temporary. They're only good for, I forget if it's an hour or 6 hours, constantly rotating. So once you have those credentials, now you can do everything to the API that EC2 instance can. And what that opened the door to was the EC2 instance could talk to S3. So now, without actually getting on that box, the attacker can now talk to S3. Then you can get the data. There's a whole bunch of things that she talks about because she kind of went on a rant about how awesome this was and clearly got caught. But you can do S3 bucket mirroring. You can share the bucket to another account, take the EBS volumes, make snapshots, just like I was talking about. So that's not a public bucket. I think this is a fascinating story. If you want to play with this stuff, go check out flaws.cloud. I have a resources link on the demo slides at the end. But it's a really cool way for free to play around with these I'm not even going to call it an exploit. This is just behavior of the API that may have unintended consequences. So flaws.cloud is a guided capture the flag. There's about 5 or 6 levels. There's 2 versions of it now. Go play with it. It's a blast. You'll learn a lot. We've talked about all the stuff you can do with S3. There are tools out there to help make this easier. So you can do recon to find S3 buckets, to find prefixes that are common and stuff that to help you dig through an S3 bucket and get to the good stuff. Tools for dumping the contents. So anything that can be done with the API, typically there's quickly going to be something that automates it to make it go way faster for you. Security services. I'll leave these slides with you for the interest of time, but basically you want to pay attention to what are the security services looking for? Are they in place? What are the configurations? And then what can we do to disrupt them? So can we delete a guard duty detector, or maybe we just want to disable it? Is that quieter? Or leave it running, but archive findings, or delete the CloudWatch or S3 integration, or leave it running, but disconnect it from the master, or work around the types of things that it's looking for. So can you get on its IP whitelist? Can you use another DNS? Can you start operating in an unsupported region so that it's not watching you at all? And very similar with CloudTrail as well. S3, if they're not paying attention to file integrity, you can mess with the S3 archival. You can delete trails, delete the buckets. These things get pretty noisy, and GuardDuty is definitely watching these actions. But you can also use it to your advantage as an attacker. So when I say embrace it, if you can read what's happening in CloudTrail, you can get an understanding of what is normal for an account and what is normal for a principal. Even down to, I know that this principal uses a Bodo 3 Python user agent, so I'm going to use that too. And I'm going to make the same calls that this user does. So now GuardDuty machine learning is not going to detect anything different. A really sophisticated security shop isn't going to notice a new user agent. A user agent like a pen test OS like Kali, that unless you forge your user agent, which isn't terribly difficult, GuardDuty will detect a pen testing user agent and alert on it. So you can find out if that's normal. We have some accounts that use Kali, and we suppress those findings because we know it's normal for that account and for those users. An attacker might see that too. And very important to note, CloudTrail is watching management events, so configuration of your infrastructure. It's not watching data events by default, and it's not watching hardly anything that's happening within EC2. So you can opt into data events. So what are the actions on running your Lambdas and accesses in your S3 buckets? Logging things like put object, get object. These get expensive because they're busy, and that's why it's not turned on. So you're going to get a really big volume on those. But really important to know that those are things that are usually outside the scope of CloudTrail. All right, so I know that was fast. Feel free to start your break now. Sarah, is there anything you wanted to chime in on for moderating?
Oh, no, I was just going to mention, Tim, everyone can go ahead and take a break right now. If you want, Tim, if you have time, like after you drink some water and relax, we could do some Q&A. If anyone has any questions, you can post it up on the chat. I know, Tim, some people were like requesting some links. I think most of them got it. But then just to double check with everyone, we're going to be sharing the slides later. So just to let everyone know. And yeah, I'll go ahead and stop recording or pause the recording for now.
I personally use Keycloak. It's an open source one backed by Red Hat. What you can do is use those enterprise credentials so you don't store your access keys locally. So you use like a special command line agent. So Okta has a CLI for AWS. Keycloak has one as well. And you kick off your session and you authenticate just like you would to Active Directory. So username, password. Typically then a huge advantage is you can layer in multi-factor. So like Google Authenticator could then be required. And you're gonna establish your session with the identity provider, which will then kick back to you the groups that you belong to, which map to the account roles that you can then assume. So that's where the scale that the previous gentleman was talking about gets really helpful. So if you're managing like 100 accounts, you log in with one set of credentials, it comes back and says, here's all the roles you can pick to all the accounts. And you pick which one you want, and you're granted temporary credentials from the assume role call. So that's not IAM, it's actually the simple token service. And they're very similar to your access keys. There's an access key and a secret access key, but there's also a session token. So you need all three of those to assume a role, and you'll see it in the demo.
Awesome. And just to let everyone know, I'm recording now. That way we can get some of the questions answered, recorded again. And then the last question was, you mentioned some methods you use to easily identify unused and unneeded resources. Can you talk about that a bit?
Yep. So I have, they're just Lambda functions. So I'm a really big fan and this costs no money. So if you want to play with something in your account, set up a whole bunch of IAM nonsense, and then get familiar with CloudWatch events or EventBridge. EventBridge is, I'm getting the understanding that EventBridge is taking over from CloudWatch events. So you use CloudWatch events to schedule running a Lambda. And it's going to be a custom Lambda, but you can find all kinds of open source stuff. And if you go to my GitHub, you see the start of a few projects. Some are fully featured. So you schedule a Lambda to run on a schedule. So CloudWatch events works two ways. It can be event-based, based on something that happened, or event-based based on like, it's now 7:16 on a Wednesday. I'm going to trigger this Lambda to run. And then that Lambda can go audit whatever you need. So you can run through IAM. You can pull the credential report for all of IAM, pick that apart, and start looking for things that you don't like. So old passwords, users that never logged in ever, old access keys. Yeah, pretty much. Other things you can do, you can now see like the last time that a role was used. So that's really helpful to prevent role proliferation. And then trying to think, you can
use trusted advisor to pull in like security groups that are wide open. Some very useful information that you can get, not only from security, but also from cost saving standpoint. Like
yeah. So Trusted Advisor does have a security aspect to it. I personally don't use it a lot, but it's a great start, especially for like a team that isn't security minded. For a lot of the things that Trusted Advisor is going to show you, I would use config rules. They've gotten significantly cheaper. So I use two different config rules. One that looks at all security groups and audits for public remote access ports, so 22 and 3389. And then I have another one that looks at all the security groups for 5 different default database ports. And anytime it finds a non-compliant security group rule, it deems that security group non-compliant, and you can trigger an event flow off of that, namely hit a Lambda and possibly yank that security group off of every instance that it's attached to, or every ENI that it's attached to. So Trusted Advisor is kind of a passive snapshot of the environment with some really good advice for some pretty obvious things that could be fixed. For the more nuanced things, I really like the event flow off of CloudWatch events and config rules.
Yep.
And there's
I mean,
a lot of, go ahead.
I see like two things, right? I mean, if you're just starting, probably like the Trusted Advisor is a low-hanging fruit because something that is easily kind of consumable and do things. I mean, if you want to really like kind of go on and advance things like you stated, some of the things that I've seen useful is with Security Hub, where it has integration with like other security services. Like for example, you can turn on like and schedule Lambda to run like a network scan on like inspector and basically pull like not only whether a particular group is open, but also the network reachability to that particular resource, like how it can reach to that resource from the internet. So it gives you more context onto the network path to see like how you can reach to that resource. So I've seen those things very useful as well to gain like more insight as you try to advance your security posture. You know?
I completely agree. Security Hub is certainly, it's becoming more and more necessary to pay attention to. We've recently implemented these CIS foundations. It's the Center for Internet Security Benchmarks. That's something that you can integrate into Security Hub now, and it will start to give you a security score on the compliance of your environment. So this is akin to any of the Azure folks out there. Security Center in Azure does that kind of gamification of your security and gives you a score. Security Hub's doing the same thing because people respond to scores, especially the people that pay money. They want to know why do we have a 44 on this account, which is actually a totally normal score. Avoidable, but.
Okay, if you want, someone, the last thing someone mentioned was if you could share your GitHub link, but then whenever you're ready, we can dive on into it, and I can stop recording if you want now.
Okay, yeah, please, thank you.
Awesome.